Welcome to our channel Education Hub. This Education Hub gives you all the education related and detail of computer science related topics. First, our lecture is right now complement subtraction in just one lecture. Before starting complement subtraction in one lecture, please subscribe our channel. If you like this video, then give the like, share our video, and also comment whether what type of improve you want. And always press the bell button to get our earliest notification of our lectures. That will helpful for your educational purpose. So let's start complement subtraction, which you get just in one lecture. Now, one thing I have to tell you, complement subtraction, why needed? Because in case of computer science, computer cannot able to subtract, division or any multiplication also. So for that purpose, if we want to do this, then obviously we have to follow by using addition operation. We have to solve all the other arithmetical operation. Let's start with that. Before that, once again I am telling that if you like our videos, then please subscribe, like and give our comments. It will be beneficial for us. Now, complement subtraction. Complement subtraction, before starting, we should know what is complement. Complement, that is base, just what we have minus basis, or base minus 1's complement. That means what the value of base is there, that base minus 1 will be minus by that values. Let's take one example or take elaborately discussion. First one, I definite complements or complements are used in digital computer for simplifying the subtraction operation and logical multiplication. There are two types of complement. These are, if I have R base system, that means base of the system, number system is R, then R complements and R minus 1, that is base complement, base minus 1's complement. When the value of the base is subtrahend, two types we received, 2's complement and 1's complement for binary numbers, or the 10's complement or 9's complement for decimal number. So if it is octal, then 8's complement and 7's complement. And in case of hexadecimal, 16's complement, 16 minus 1, that is 15's complement. So basically complements are for our base and base minus 1's number. Now, in case of the binary, that means in computer science, we are very much used two number system. One is obviously binary, and we are very much familiar with decimal. So here also we will discuss about decimal numbers complement system also. Now let's take one example. That is R's complement. Given a positive number n in base R with an integer part of n digit, there R's complement of capital N is defined as r to the power smaller n minus n. that means n is the number in base r and the integer part of n digits. So n equal to 0 and 0 for n equal to capital N equal to 0. So if n not equal to 0 and n for 0, the examples we are taking, the tens complement of suppose 5 to 5 to 0 is 10 to the power 5 because we have 5 digits minus 5 to 5 to 0. Now the number of digits in the number n, suppose tens complement of 0.3267. So 1 minus 3267 gives you the complements. Now let's take the example of r minus 1's complement. If a positive number n of base of r with an integer of smaller n part of digits, then r minus 1's complement of n is defined as r to the power capital N minus r to the power minus m minus capital N. So 9's complement of the same number, that is 5 to 5 to 0, will be 10 to the power 5 minus 1 minus 5 to 5 to 0. That is 5 9. From there you have to deduct 5 to 5 to 0. Now for examples, we see that 9's complement of a decimal number is formed simply by subtracting every number from 9, and 1's complement of binary number is even simpler to form, that is 1 is changed to 0 and 0 is changed to 1. So r minus 1's complements is very easy to obtain. Sometimes for convenient use, we are using r's complement is desired. So for that purpose we have to know the r's complement also. So from definition, comparison of result obtained, for example, r's complement can be obtained from r minus 1's complement, and after that addition of r to the power minus m. So we have to do this way. Let's use right now the subtraction with r's complement. The direct method of subtraction taught in elementary schools to using the borrow steps. This method we borrow 1 from higher significance and positive position of the minute digit is smaller than the corresponding subtrahend digit. This seems that easiest when the people perform subtraction with paper and pencil. When the subtraction is implemented by means of digital components, this method is found to be less efficient than the method that uses complements. So for that purpose, we follow complement method subtraction. Now here add the minute, that is m, to the r's complement of the subtrahend n. Impact the result obtained in steps 1 and end the carry if and end carry discarded, and if end carry does not occur, take r's complement of that number obtained in step 1 and place a negative sign in front of that. Let's take one example and we will explain it once again. So just one brief, that is for r's complement I have to take the subtrahend and then we have to add with the minute of m. And if the carry is coming, then we have to discard. If the carry is not coming, so what the resultant will come, that will be again make the r's complement and give a negative sign in front of that number. So it will be your result. Let's take the example right now. Now here I am taking the example of decimal numbers, that is the r's complement I have to take. See, this is the example. I have to subtract 72752 from there 3250. So m is right now 72532 and n is 03250. Now 72532 will be intact, and I have to take the n's complement and r's complement, that is the tens complement here of n, that will be just 69750. Wherefrom we are getting that? That is, we have to take the base, that is 10 to the power 5 right now. Not 5, here it should be 3. Sorry, 4, or 10 to the power 5, because 5 digits is there, minus that number 303250. What we will get? Now add this both number. We are getting 69282. So the answer is that. Now just the opposite if I am taking, that is m is right now 03250 and 7252332. Then first, that is the 03250 will be intact and tens complement will be 27468. So no carry, we will get 30718. Now I have to make the n's complement, that is the tens complement of this number, and give the minus sign. So negative 69282 will be the answer. So in first case, where the smaller number will be subtracted from a larger number, there we are adding something, we are getting some carry also, and discarding the carry, we are getting our resultant value. So that value will be positive. Now in second case, the negative value is not coming, sorry, the carry is not coming, so it will be, the result will be negative, and for that purpose what we are doing, we are just taking the result, making tens complements once again, and give the negative sign in front of that number. Just go through it once. Now subtraction with the r minus 1's complement. The procedure of subtraction with the r minus 1's complement is just exactly with the r's complement, but just there one variation. It is called end around carry, as shown in below. Here what we have to do, subtraction of m minus n, both positive number of in the base of r, is calculated with a manner of that add m, that is the minuend, to the r minus 1's complement of the subtrahend. Implement the result obtained in step 1 and end carry. If the carry is occur, then add 1, discard the carry and add 1 with the least significant bit. And if does not occur the carry, then take r minus 1's complement of that number and take the negative sign in front of that number. So for that purpose, take one example, it will be clear to us. So making it clear, we have to discuss something. Just before starting the example, just once again, please you go through the slide. Before starting, I repeat once more, I have to take the r's complement of n, that is where what we have to subtract, then we have to add both. If the carry is coming, discard that carry, add 1, add that carry with the least significant bit, and if there is no carry, then take the resultant value r minus 1's complement once again and give the negative sign in front of that. Now let's take the example, m equal to 72532, n equal to 03250. So r's complement means m will comes intact and we are taking just the opposite of that, that is 0 should be 9, 5 means 4 obviously, because the 9 is there, that means 1 borrow sign should become here. This way if we proceed, we are getting 96749. Now ending carry, that is 1, is added with the least significant bit and we are getting 69282. So that will be our answer. Just in opposite, if I have to deduct, that is 03250 will be m and n should be right now 725320. Then what we have to do? That is 3250 minus r minus 1's complement, that is 2 is coming as. Now we add, there is no carry, so I am taking once again the values r minus 1's complement and give the negative sign. Just go through, it will be helpful for you. Now take 1's complement method. We already discussed an example, that is 10's complement and 9's complement. Now I am taking 1's complement method for binary, where the m value is 1 0 1 0 1 0 0 and n value is 1 0 0 0 0 1 0 0. So we add the complements of that. n r minus 1's one's complement will be r minus 1's, means here the 2 minus 1 1's complement, that will be just exchange of 0 by 1 and 1 by 0. So we are getting this number. Now we are adding this both. If the carry is coming, here the carry is also coming. I have to discard this carry right now and add with the least significant bit, and we are getting the resultant as 0 0 1 0 0 0 0. Now for 2's complement, what we have to do? The same process. Let's take 1 0 0 1 0 0 will be right now comes in as a intact, and the m value 1 0 1 0 1 0 0 will be just take the 1's complement of that, then plus 1, that is gives you the value of 2's complement. Now add both, the carry will come, just discard it. And if there is no carry, in the next example you can get. So make the r's complement, that is 2's complement of that number once again, and give the negative value. So we are getting the number minus 1 0 0 0 0. Now after taking this value, before leaving in every steps, I am showing it once more because you are able to read it. Now the comparison between 1's complement and 2's complement, several times in your exam you will get this type of questions. So for that purpose I write down this also. The comparison between 1's complement and 2's complement reveals the advantage and disadvantage of each one. One's complement has advantage to being easier to implement than 2's complement. The implementation of 2's complement may be obtained in two ways: by adding 1 to the least significant bit digits to the 1's complement, and by leaving all regions on zeros, the less significant bit position at the first one is unchanged, and only that changing all the ones and zeros into ones, we are able to get the result. Now during the subtraction of two numbers by complement, 2's complement is advantageous if and only if the arithmetic addition operation is required. So 1's complement requires two arithmetic addition when ends around carry works. But in 1's complement has the additional disadvantage to preceding two arithmetic zeros 0 with all zeros and shall be 1 for all ones. Please go through it. For each and every slides, I am giving the time to read it by own. So I think right now you are able to study. Let's change the slide right now. The next topic and the next discussion we have to start. So the study is over right now. Let's take the next one. So after that, let's start the discussion. Some illustration examples is given here. Just go through it. I don't want to explain it once more, because if it is 1100 minus 1100, it will give you 0, and in case of 1's complement, it will give you 1100 plus 0011. So 41 will be come to our side. Now again, if I have to take the complement of that number, because no carry is coming, so it becomes 4000s. Now in case of 2's complement, that is 100 plus 0011 plus 1, that is 100. Now we add, we will get 4 zeros, because one carry will come and I have to discard it. I think you can able to get it once more. So that is enough for today. I think we can able to get. Before ending, once again I am telling that please like, share and subscribe our channel, and obviously please go through it. And if you need any type of modification, what will be helpful for us, so please give comment, and if your comment will be precious for our improvement. So thanking you. Have to